Welcome to the SWAYAM NPTEL course on mechanical and electrical systems of mining machines. So this is the 14th lecture on internal combustion engine, which is a part of module 1, fundamentals of mechanical systems in mining machines. Now why this topic is important? Because this is the major power source of all the heavy machineries that is being used in mines. So if we see any of these mining machines, so this is the powerhouse of these machines. So the concepts that would be covered in this topic is, first we will be going through the introduction of heat engines, and then we will be classifying the heat engines in two different categories majorly. We will be going through that, and then we will be going in details of internal combustion engine, and then we will be understanding the nomenclature of these engines. Now, what do we call as an engine? So, engine is a device which transforms one form of energy into another form of energy. Well, when we talk about any engine or a device which transforms one form to another, we always talk of how much efficient it is and how much is the work done to get the required efficiency. So most of the engines that convert any thermal energy into mechanical work are called as heat engines, because they use the heat energy, that is the thermal energy, to convert it into some useful mechanical work, and that defines, with these parameters we can define the efficiency of that engine. So one of the simplest cycle of the heat engine is the Carnot cycle, which you can see in this picture. There is a hot reservoir and then there is an engine in between. So this engine in between takes the energy from the hot reservoir, takes the thermal energy from the hot reservoir, converts it into some useful work, and release out or dumps the balance amount of energy to a cold reservoir. So you can see there are two reservoirs, one is a hot reservoir and then another is a cold reservoir. So well, when we talk about this kind of engine, we call it as a Carnot cycle. However, the heat engine is also a device which transforms the chemical energy of a fuel into thermal energy, and this is utilized to perform some useful work. Well, when we convert the thermal energy into mechanical energy, so this kind of machines or engine we have seen it in form of a steam engine. Now steam engine is a type of heat engine. We will be discussing of the construction of a steam engine. Well, when we talk about the steam engine or the engines that are being used in our vehicles, in our automotive vehicles that we are using for getting ourselves transported from one location to the other, or in mining industries when these vehicles are used for transportation of material from one point to the other or to do some kind of useful work. So there are certain types of engines that are used. So when we broadly classify these heat engines, we classify them into two categories. One is an internal combustion engine and the other is a external combustion engine. When we talk about this steam engine, where there is a water and then this water is given some heat input which is converted into steam, and this steam helps in the reciprocation of the wheel that we may have seen in various locomotives. So this is a type of external combustion engine. So when we talk about locomotives, it is one of a major machinery that is being used for transportation of material from one point to the other in the mining industry. However, in most of the machines, like in dump trucks, in shovels, in surface miners and many other machines, we see there is an internal combustion engine. So what is this internal combustion engine? We will be learning in a while. Before that, let us see how do we classify the heat engines. Well, we classify the heat engines majorly into two types. One is the internal combustion engine and one is the external combustion engine. Let us first try to understand what is this internal combustion engine as its name says. So, when we talk about the internal combustion engine, so this combustion is happening somewhere in a closed chamber. So, that is why we call it as an internal combustion engine, as you can see in this picture here. So, here you can see this is the combustion chamber, and here this is one of the piston, and this is a cylinder in which the combustion chamber is present, and this is one of the connecting rod, and this is the crank. So, due to the combustion that takes place inside this cylinder, that is the combustion chamber, so there is a energy that is released due to the combustion of this the fuel, which converts the fuel energy into mechanical work, and it helps in the rotational movement of this crank. So, the same way when we see what is a external combustion engine. So, in an external combustion engine, so there is a loop of mechanism where the reciprocation and rotation of different component happens. However, the energy is given externally. So, as you can see here, so here is a chamber where the combustion happens. So, there is a coal which is when it is burnt. So, the combustion of this coal happens, which heats up the water. This water is now converted into steam. Now, this steam helps in to and fro motion of this piston, which results in the reciprocating motion of this connecting rod, and which again pushes this crankshaft, which results in the rotational motion of this wheels. So, as a result, you can see here the combustion is happening externally. However, the mechanism that helps in the movement of the vehicle, which we call it as a steam engine, is happening in a separate mechanism where there is a water and the steam externally is forcing the piston out, so that there is a continuous reciprocating and rotary motion of reciprocating motion of the crankshaft and rotary motion of the wheels that can happen due to the combustion which is taking place externally. However, that is not the case in an internal combustion engine. Well, we will be going in details with the understanding the internal combustion engine, because nowadays we do not see an external combustion engine that widely. So, that is and in most of the machines that is being used either in the buses or cars that we travel, we have an internal combustion engine, and also in the mining industry, the machines that you have gets the power from a certain source, they are from the internal combustion engines. Now, when we talk about the internal combustion engine, they are again of two types, that is rotary and reciprocating. The external combustion engine is also again of two types, that is reciprocating and rotary. Again, in rotary there are different types of internal combustion engine, and in reciprocating there are different types. In reciprocating, we have the gasoline engine and the diesel engine, which we will be studying in details in this topic, in this chapter that we are going through now. However, in external combustion engine, when we see for reciprocating, we have the steam engine, which I have explained briefly. There is also Stirling engine. If you are more interested, you can use different sources to learn about them. However, this course does not have the bandwidth to cover all the different types of internal combustion engine and external combustion engine, as this is not being used in the mining machines. Well, in rotary type external combustion engine, we have steam turbines and closed cycle gas turbines, which you can find while you search in through various sources. When we come to the basics of an engine component, let's say there are two different types of the internal combustion engine. So the first one is a petrol engine, or it is also called as the gasoline engine, and the second type is a diesel engine. So this petrol engine or the gasoline engine is also called as the spark ignition engine, which we also call it as the SI engine, and this diesel engine is called as the compression ignition engine, which we call it as the CI engine. Well, the basic structure of this petrol engine and the diesel engine is very much similar with certain differences. What are the differences? I will be letting you know in a while. But when we talk about this internal combustion engine that is being used in various vehicles or heavy machineries, these are the only two types that we would see. That is, in light vehicles we would see the petrol engine, however in heavy vehicles we would find the diesel engine. Why? We will be understanding in this chapter. Once we finish this chapter, you will have a clear idea of why a diesel engine is used in heavy machineries while a petrol engine is not. Well, let us come to the construction of this two types of engines, that is the petrol engine and the diesel engine. So in both of these engines, so there is a cylinder and a piston. So this is the cylinder and inside it there is a piston. So this is the cylinder and this is the piston. Now here on the piston there is a pin to which a connecting rod is attached. What is this? This is a connecting rod. Now there is again another pin to which there is a crank which is attached to this connecting rod. Now this crank is again attached onto a shaft which we call it as the crank shaft. Well, this pin onto which the connecting rod is attached onto the piston, we call it as the gudgeon pin, and the pin onto which this connecting rod is attached to the crank, we call it as a crank pin. So now this crank takes a rotary motion so that there is a reciprocating motion of the connecting rod and the piston inside the cylinder. Well, above this cylinder, the cylinder is a closed chamber. So this is a closed chamber which we call it as the combustion chamber. So we have two valves. So this valve is called as the inlet valve and this valve is called as the exhaust valve. Again, to this inlet valve and exhaust valve, we have two manifolds which we call it as the inlet manifold, and we call this as a exhaust manifold. Okay. So, now there are certain basic differences of this petrol and diesel engine. First of all, I am telling what is common between these two engines, and then I will be going to the differences. So, these are common to both the petrol engines and the diesel engine. Now, here we have a case which we call it as a crank case, which goes from the cylinder and down onto the crank. We call it as a crank case, and at the bottom we have this cover which is a part of the crankcase, but we have the sump where the lubricating oil is there, which lubricates the different parts of the engine. So, now what is the difference between these two? So, this all are the common parts of both the petrol engine and the diesel engine. So, the two parts which are different or which are present, two parts which are present in SI engine are the carburetor and the spark plug. As the name says, in the petrol engine, it is also called as the spark ignition engine. So, in between this inlet valve and exhaust valve, there is a component which ignites the combustible material. So, which we call it as the spark plug. And where does the carburetor lies? So, here there is a chamber where the air and fuel gets mixed up. So, here the air goes in and from here the fuel goes in. The air plus fuel gets mixed up in this chamber before it goes into the inlet manifold. So, this we call it as a carburetor. So, these two parts are present in SI engine. The part that is present in the CI engine, that is the compression ignition engine. So, in CI engine we have a high pressure fuel injector. So, in place of the spark plug, this is in SI engine. So, here we have a fuel injector, high pressure fuel injector in the CI engine. So, this is the basic constructional difference between a petrol engine and a diesel engine. Otherwise, there is no carburetor in a diesel engine, there is a carburetor in an SI engine, or else the all other components in both the petrol engine and diesel engine are same. So, the piston would move from the bottom of this cylinder to the top of this cylinder, which would reciprocate from the bottom dead center to the top dead center, which we tell it as the bottom dead center BDC to TDC, to complete different cycles. Now, we have something called as a 4-stroke engine and 2-stroke engine. So, what do we understand by strokes? So, let us go to the nomenclature. of this internal combustion engine. So the first point is the cylinder bore. So the inner diameter of this working cylinder, we call it as the cylinder bore or cylinder diameter, and it is denoted by small d. Now the piston area, the top of the piston, the surface area of the top of the piston is designated as a piston area. So we understand that the cylinder, the cross section of a cylinder is a circle, and a piston which moves inside this cylinder is also circular in nature. So the top surface of this piston, which is circular in nature, gives the piston area. Now this when we talk about this piston area, it is given by pi by 4 d square. What do we understand? That the outer diameter of this piston is almost equal to the inner diameter of the cylinder theoretically. However, practically there will be certain clearances which we neglect while we calculate the piston area. Now when we talk about strokes, as I mentioned, there is something called as a 4-stroke engine and there is something called as a 2-stroke engine. So when we talk about a stroke, so when the piston moves from one end to the other end, so that is the length of the cylinder. It is not the complete length of the cylinder, but from the point from where the piston moves inside the cylinder from one end, from the lowermost end to the farthest most end or the topmost end, we call it as 1 stroke. So let's say this is the cylinder. So and this is the point from where the piston would start moving inside the cylinder. So here is the gudgeon pin. Now this is the connecting rod, and this is the point where it is at the bottommost point of the circle of the crank. So this is the circle of the crank that the crank would rotate in this path. So it is at the bottommost point. So from this point to the point, let's say the crank would move from this point to the other, now pushing the connecting rod to be at the topmost point. So where my piston would move till this point. So this, from this to this, we call it as 1 stroke. So when this crank makes a half circle, so we call it as 1 stroke. When it completes the full circle, we call it as 2 strokes. So there are certain engines where we have 2 strokes and where we have 4 strokes. So in this 4-stroke engine, there will be 4 processes which happens in each of these strokes. However, in 2-stroke, there will be 2 processes that would happen in each of these stroke. So now I will be talking in the subsequent lecture, I will be talking about what are the different processes. But in this lecture, I will be only making you acquainted with the terminologies that we would be using in the subsequent lectures. So then there is another term which we call it as the stroke to bore ratio, that defines what kind of engine do we have. So this stroke to bore ratio is given by L by D. So that gives the size of the engine. So let's say if my diameter is less than my length, so it would be looking somewhat like this. My diameter is less than my length. So this is called as a under square engine. However, when my diameter and my length, so let's say this is my length and this is my diameter, my length and my diameter both are equal to each other, we call it as a square engine. And when my diameter is very large than my length, we call it as a over square engine. So, what do we say? That an over square engine can operate at high speeds because of larger bore and shorter strokes. That is quite self understandable. Then there is something called as dead centers. So, we have a bottom dead center and then we have a top dead center. As I was explaining, the point from where my piston would start moving from the lowest most point, where my crank is also at the bottommost point of its circle, we call it as one point, and then there is another point where my piston is at, when my piston is at that location, my connecting rod would be also on its topmost position and my crank will also be at its topmost position. So, this point we call it as a bottom dead center, that is the lowest most point, and then at the topmost point we have something called as the top dead center, that is the farthest point from the crankshaft. The piston is farthest from the crankshaft, and for bottom dead center the piston is nearest to the crankshaft. Well, when we talk about the different volumes, there, as I explained you, that when we talk about a stroke, it is not the complete length of the cylinder, it is the certain length of the cylinder that the piston can traverse. So, when we talk about this volume of the cylinder, we call it as the swept volume or the displacement volume, in which my piston can move from one point, that is the bottom dead center, to the top dead center, which is given by area of the piston multiplied with length, which is pi by 4 d square L. Now, when we talk about the engine capacity, you would have seen in various advertisements, or you would have seen in any garage, if you would have opened the bonnet of your car, you would have seen that it is not only one cylinder, but there are multiple cylinders which are there in an engine. So, the engine capacity of any vehicle is given by the swept volume multiplied with the number of cylinders, which is given by Vs multiplied with K. K is the number of cylinders in any engine. Now, there is another volume which we call it as the clearance volume. Now, I have been mentioning from quite some time that there is certain section of a cylinder that the piston can traverse from one point to the other, that is from bottom dead center to the top dead center, which we call it as the swept volume. However, there is some remaining volume which is almost we can say where our valves are there, or our valves occupy that space, which we call it as the clearance volume. So, my total volume of the cylinder would be, total volume is swept volume plus the clearance volume. So, we can say that if my cylinder has certain volume, how do I find the clearance volume? It is total volume minus the swept volume. So, that small area that lies on the top of the cylinder, after my piston reaches the topmost point, it can reach inside the cylinder. The volume that is remaining at above the piston, we call it as a clearance volume. Now, there is a term called as the compression ratio that defines the efficiency of any of this engine, either it is a diesel engine or it is a petrol engine, it is defined by its compression ratio. So, what is this compression ratio? It is given by this notation R, which is equal to the total volume divided by the clearance volume. So, let us say the complete cylinder gets filled with air fuel mixture or air, then it gets compressed into that smaller volume, that is the complete volume that gets into the cylinder gets compressed into that smaller section or the smaller volume, which we call it as the clearance volume. So, that is given by this compression ratio, and it is given by this notation of R is equal to total volume divided by the clearance volume, which again we can write it as Vc plus Vs by Vc, which is equal to 1 plus Vs by Vc. So, generally when we see for any spark ignition engine, my compression ratio is around 6 to 10, but however for a compression ignition engine, that is a diesel engine, my compression ratio goes as high as 16 to 20. So, this defines the efficiency of a diesel engine is higher. There are other factors which also leads to why it has a higher compression ratio and how its efficiency increases. We will be discussing in the subsequent chapters. So, this is the reference for this class. You can refer to V. Ganeshan, that is the internal combustion engine book by McGraw-Hill. We will be discussing more on this topic in the next class. Thank you.